Here's a Gladding McBean Cordova roof tile roof that I put together. There might be some ideas that somebody could benefit from who's going to put a mission tile roof up. They're just ideas, it's kind of experimental. The three main areas are the ridge. I did the ridge my own way. I really like the way I did the ridge. I think it's got a lot of potential. It's completely different than what the manufacturer recommends. The second thing that I did different is how I run these tiles out on the edge of the roof. And there's no cut tiles there. The cap tiles are full length and the pan tiles are full length. And the cap tiles stick out even, or maybe a little bit past the end of the gutter there. I'm going to climb down here. You can see what it looks like from below. So looking straight on, I think it looks really good. You can't tell that it's been done in a different way than standard. The third area that I experimented and did something really different than standard is the gable ends. I've got cement board. I've got the Durock cement board as a fascia board, and it's plastered. And I've got these tiles wired on with stainless steel so that wind doesn't catch them and flip them off of there. I think it's a really good system. It's a paint-free, fire-resistant way to do the gable ends on a tile roof, and I haven't seen anything like it. I think that's got a lot of potential. So coming up will be instructions on how I put the whole roof together. Obviously, if you're going to do a tile roof, you better get somebody who knows, a pro, a roofer. If you're thinking of using some of these deviations, some of these experiments for manufacturer spec, somebody who can judge them on their merit. Nothing I'm going to show you is a recommendation. It's all just experimental. I'm just putting it up on the internet so somebody can look at it and maybe get, if somebody gets one good idea out of this video that helps them put up a better roof, then I will have succeeded. Okay, here you can see the roof deck, which is out of 2x material, 2x6, 2x8, 2x10. Doug fir boards, which don't cost that much more than a plywood roof deck. A little more labor to put them in, obviously. Here's a 2x6 fascia board that's going in behind the gutter. I've ripped it to match the 8 and 12 pitch on the top, so the outside edge here is only 4.5 inches high. There you can see that piece of 45-degree cut fill in there, and there's a half of a 2x6 that I ripped and screwed it to this 2x8 barge rafter while it was on the ground. Okay, then the barge rafter is screwed into the roof deck. The barge rafter is screwed into the roof deck on the outside here too. I used regular 3-inch deck screws. And the roof deck is screwed up into the ripped 2x from underneath, sucking it all in tight and flat. Got some sheet metal I bent here. This piece of flashing is to go behind the gutter. And that 5 1/4 inch dimension there, that's about 3/4 of an inch, 7/8 of an inch more than the 4.5 inch dimension on the ripped edge of the 2x6. The extra 3/4 inch or more is for stucco. You can see I've got a little stucco screed edge there. And then it goes down below that 5/8 of an inch for a drip. Okay, and it laps up onto the roof about 4 1/4 inches. 5 1/4 inches was too narrow. It should have been 5.5. This was made from a piece of 12-inch wide sheet metal. Okay, this piece is going to go on the end of on top of the barge rafters. Comes down 1 1/4 inches here. This piece is made from a piece of 13.5-inch wide sheet metal. Here. Note that I've got some 1/4 inch returns bent on both edges. 3 1/4 on the top, little bit wider than the thickness of the doubled up 2x lumber to allow for the thickness of some tar paper and stuff under there. I've got 8.5 inches here, which is 1.25 inches more than the width of the 2x8 to allow for the thickness of some stucco and still leave a drip edge below it. Here's a corner detail. Here's this piece with a right angle bend on it that ended up being put on the end here. You can see how they're interlocked. I'm going to nail it off now and caulk it with some gutter lap sealant. Here's the end result. Here's the same detail. It's the other corner of the building from down below. You can see the bottom flange that the stucco is going to go behind could have been down another 1/4 inch, which means I would have to have made the face of the sheet metal another 1/4 inch longer. I'll just bend the flange down on a little bit of an angle and it'll work. Which is what I remarked just a minute ago in the voiceover. So there's enough thickness for the stucco to fit between the lip of the metal and the wood. Here's a shot from a little further away. You can see where I've rolled the tar paper out and I put some roll roofing on. I consider the roll roofing to be cheap insurance. Doesn't cost that much, gives you a lot better roof. Use the white to reflect the heat and the sun. You can see here on the ends how the tar paper just rolls up over that piece of 45-degree fill that I put in there. It just supports the tar paper better. And I'm cutting the tar paper off flush with the top of that bar drafter. I'm lapped over the edge here, hanging over the edge 1/2 inch, 3/4 inch. I'm using a cheap gutter they've got at Lowe's that you just add on afterwards. Doesn't go back up under, is why I don't have the gutters on now. You just put them on later. I've got the roll roofing all done. And I've put some bituthene around the ends of the bar drafters to really seal that up. I had the bituthene. It's real expensive, but it does a really good job. Kind of a problem solver. There's probably something else that could be used that's not as expensive that would serve the same purpose. Wrapped it up underneath. I've placed this piece of sheet metal cover over the bituthene and the pressure treated bar drafter. You can see it hangs down here inch or so. It's going to be stuccoed up there under the soffit. Stucco will probably almost come out to the edge of the sheet metal, not quite all the way down to the bottom of it. It's kind of bending around here. Most of it's going to be covered by the gutter. There's a piece of tile there. The center of that tile, you can see the chalk line up there, is about 4 1/4 inches from the edge of that sheet metal there, up at the top, up at the top edge where the 90-degree bend is. Then I've got 11 1/4 inch centers. The manufacturer specs out 11 1/2 inch centers. I've had these down under 11 a little bit. I wouldn't go over what they spec out, 11 1/2. I've played with the tiles, and they work up to 11 1/2, and they work good under that. But I don't think going over 11 1/2 is going to be a good idea. So I've snapped my chalk lines at 11 1/4. That distance happens to work out nice because 4 times 11 1/4 is 45 inches. You double that, you got 90 inches. So we got kind of a 90-inch increment working. Also, if you go across these two edges of this tile, they're about level with the top of the sheet metal. Here's a 3x5 sheet of Durock. It's been ripped into 8 and 7/8 inch wide strips with a diamond blade. I'm going to use these to cover the sheet metal on the outside of the barge rafter, and then I'll plaster it. So the barge rafter will actually end up being plastered. And of course I'll put the rough side out so the plaster can get a better bite on it. Here's the jig I'm using to cut the very top course of roof tiles. Here's a pan tile being cut on here right now. The angle in here is about 29 or 30 degrees. You'd expect it to be something like 32 or 33 for 8 and 12 pitch, but the tiles don't sit flat on the roof. They angle up because each one rests on the tile below it. So you have to take a little bit off of that 8 and 12. Here's a cap tile in it, about ready to be cut. Here's the Durock nailed on the end of the barge rafter. It's flush on the top edge with the sheet metal. Extends a ½ inch below the bottom edge of the sheet metal. The nails I use here are stainless steel ring shank nails. I don't want the heads to rust and the rust to bleed through the color coat and there be a mark on the color coat. Here's the top tiles on the roof. The cap tile is going to be full length. They're 18-inch tiles, so it's a full 18. Now, I cut that 29-degree angle on the top. You can see it wired together with the one on the opposite side. I'm just using 045 stainless steel welding wire. I'm using 18-inch tiles. The pan tile should be the length of the exposure, which in this case is going to be 13.5 inches, which would leave me with 4.5 inches of headlap. But due to the way these are cut, due to the extra thickness above the ridge, the extra height there, you can see it's like 2.5 inches. To get that 4.5 inch difference in the length between these two, to get that 4.5 inch difference from here to here, it actually ends up being 12 inches, measured right across there. And you can see where I've got the 045 wire. I put 2 wires so that it doesn't just hit right on the ridge. It kind of creates a little more space under there. That's that same 045 stainless steel wire. Here's a look at how these will actually fit. There's the 4.5 inch of headlap right there. Okay, I'm going to go over how I split up the length of the roof here to figure out the exposure on each tile and where to place them. Okay, the bottom tile is going to run by the edge of that rolled roofing ½ inch. So when you're measuring with your tape measure, just stick it out ½ inch past that. Okay, and up here at the top, just for the sake of measurement, we've only got 12 inches there from the ridge. Add that 1.5 inches back on. So measure 1.5 inches past the ridge. So overall, if you took the exact measurement, then you add ½ inch on the bottom and 1.5 inches at the top. That adds 2 inches on. That gives you your total length. Divide that by the number of courses. You might have to, experiment, do the math on a couple different number of courses till you home in on your correct exposure, and then you got it. Gladding McBean, originally years ago had on this exact identical tile had a 14-inch exposure with a 4-inch headlap. And then they switched it to a 15-inch exposure with a 3-inch headlap. To me, 3 inches is just cutting it right down to the wire. I'd like a little bit more than that. So personally, I wouldn't go over the 14.5 inch exposure and a 3.5 inch headlap. I think they did that so that it would minimize the number of tiles. It would make the cost per installed square look a little lower. Maybe somebody would, anything they can do to get the cost down to get somebody to use it instead of somebody else's product. So anyway, for this roof I did the math. I've got 13.5-inch exposure, which I have marked out here. And this is the exposure here. These lines are not the top of the pan tiles. That's where the actual exposure will be. So since I've got 4.5-inch headlap, the pan tiles are going to go 4.5 inches above that. But it makes it easier to do the math when you're working with the exposure. You mark out the exposure. So here you can see, here's my mark, and that pan tile is actually 4.5 inches above it. So, you know, this is just how I do it. There were some things I wasn't too happy about with the way Gladding McBean had it spec'd out. Their system has its advantages, this one has its advantages. So, you know, look at both of them and, you know, try to figure out how things actually will work in your installation. Maybe something I'm doing here will have some value.